Hi, let us understand more about the Minikube and the Istio installation as well as the sample application we installed as a part of the Minikube installation. This is the instance where I did the installation of Minikube. Now I am going to log into the instance once again and check the status. As I mentioned in the EC2 introduction lecture, you will be stopping this instance whenever you are not using it. Also, you may stop the Minikube installation in your local machine as well. So I'm going to provide the steps, what are all the things needs to be taken care after restarting the instance or restarting the local Minikube installation. Let me log into the instance. And as I mentioned, as a part of EC2 introduction, I need to make sure the security group is open for my IP address. Always I do open the port only for my IP address. And here I have opened all the ports only for my IP address, majorly for the security purpose. Let me open the instance. And as a part of the installation, I added the Istio bin directory as a part of the profile, and I need to source it whenever I am logging in. And the best option is to add it as a part of the environmental file available within the etc directory. Let me log in as super user. Within etc directory, there's going to be a file called environmental file. Here I have added the location where Istio bin directory is available, and that's going to automatically add this location as a part of the path, so that the Istio CTL will work from any location. Whenever I provide the command Istio CTL, it's going to provide the notes on the usage. That means the Istio CTL it's able to recognize. I can check the status of Minikube. It is in the stopped state. I can go ahead and start them. Minikube, start. And any pod, if it is deployed, for example, the sample applications, it will be existing and it's going to restart them. And very important point to be noted, let me remind once again, always make sure the Istio injection equal to enabled label is added to the namespace where you are going to work with Istio. In our case, we enabled the Istio injection as a part of the default namespace. I can make sure and verify whether the label is added by using the describe command. kubectl describe namespace default. Here I do have the label Istio injection equal to enabled. So any pod that is getting created within this specific namespace will have two containers within it. That's why any pod that is getting created within this namespace will be having two containers. Let me go ahead and get all the pods available. I can check all the entities that are available as a part of all the namespace using the command kubectl get all -- all namespaces. As I have already installed the Istio, I do have the deployments for the Istio system, and when it comes to the pods, I do have the pods for the Istio system as well as the Cube system. These are all the pods that are required for the Kubernetes to work and got started because of the Minikube installation, and these are all the pods that are being used by the Istio. We will be having a detailed discussion about each and every pod and its role later when we are discussing about the architecture. Now let me go ahead and add the sample application by running the bookinfo.yaml file available as a part of samples folder. This is where I install the Istio. Within the folder, as we discussed earlier, we are having the samples folder. I'm going to run the bookinfo YAML file available within the samples folder. kubectl apply -f and then the bookinfo YAML file. This is going to deploy all the required entities like deployments, services, service account, pods, and all the entities would get created. Now let me go ahead and check all the entities as a part of default namespace. As I did not provide any namespace, it's going to get created within the default namespace. kubectl get pods. Here I do have 6 pods, and few of the pods are in the initializing state and few are in the running state. Finally, it's going to create 2 containers within the pod. As we discussed earlier, it's going to inject the proxy container as a part of each and every pod. The reason because we do have the label Istio injection equal to enabled added as a part of the default namespace. Let me go ahead and get the status of the pods once again. Yes, each and every pod is having 2 containers, and both the containers are running fine. That's why we do have 2 by 2. I can get the details about any single pod using describe pod command. So within the pod, I do have 2 containers. One is the init container that is using the proxy v2 from the Docker registry, and the same way I do have another container, example book info details. This is just to have a feel on that specific container will get injected into each and every pod. I can check another pod as well. Let me get the detail about this particular pod. This should also have 2 containers. Here also I do have init container that's coming from the proxy v2 and another container for its core purpose, and that is example book info product page. Now this particular application is up and running, and we need to have a way to access this particular application. I can go ahead and use the CURL and access in the port 9080. That's where the service is running. Let me go ahead and get all the services running using the command kubectl get services. So the product page is running in the port 9080, and it is accessible from the cluster IP address 10.104.159.153. If I have an external IP address, then I can access it directly, or I need to expose this to access the application. And there is one another easier way where I can use the putty tunneling. Since I am using the putty to access the AWS EC2 application, I can use the putty tunneling. I will be having a separate session on how to use the putty tunneling. And sometimes there may be a need to install the sample application afresh, and I can go ahead and do the cleanup and do the installation of the sample application once again. For that, I will be executing this particular script, samples/bookinfo/platform/cube/cleanup.sh. It's going to ask the namespace where that particular application needs to be cleaned up. I'm going to use the default. It will delete all the entities that got created as a part of the sample application. So I can check whether all the virtual services, definition rules, gateways, everything got deleted or not. Don't worry about the virtual services, destination rules. We will be creating it while doing the demo. Now all you need is whether the pods got deleted or not. Yes, the last pod that's also getting terminated. So I can install the sample application a number of times, and I can access them as well. And we are going to see how to access this application using the putty tunneling as well as using the CURL for our demo purpose in the next lecture.